In this brief collection of videos, we are going to introduce power series and talk about how we go about finding what's called either the radius or the interval of convergence. So what is a power series? There's a formal definition that's written up here on our screen, but here's the behind the scenes picture. We've been working with series on their own for a while now, and they're starting to get a little bit boring. So when a mathematician says, let's make this more interesting, that's where power series come from. We don't have enough going on in our series already. What I'd like to do now is kind of generalize the same way in which automatic homework assignments generalize problems when they're generating random different iterations of that problem to show us. What we're going to imagine is that we have a series. So we have the big sigma out in front. The a's of n's that I'm visualizing here are things like we would always imagine we would have seen before, some sort of formula involving n's, the variable that has to do with the sum. But then inside of every single term, we also want to see a bunch of other things. We want to see the variable x, subtract from that some constant. So this c inside of an actual power series example will be a number that's filled in. It will not be a letter at all. It'll be something like 2 or 5 or frequently 0. But the x will be in there in that form as the variable x. But that thing, the x minus c, that's going to appear in every term is going to be raised to the nth power, where that n variable is the variable being controlled by the sum. So again, the c will be filled in. That will be a numerical value when we look at an example of a power series. We're going to have kind of think about them as coefficients right here, which is some sort of formula that involves just n's the way that a normal series would. And then we'll also, more interestingly, have this x running around in our series. And we're going to think about the x as something that we can plug in different values for. When the c is plugged in, and then we plug in a specific value for the x, this whole thing will turn into just a simple series. So we're thinking about x the way we normally think about x, this variable that we have the power to plug in values for. And that's precisely what we want to think about with power series. I've put an example of one right here. We're going to now think about this whole series as a function of x. I could plug in different values for x, do a computation here, and what I would get is a series. And I want to know when that series converges, and what we're planning on studying are the different x values we could plug in for this function that might make the series a convergent series. When does this make sense? When does this not make sense? What different values of x will give us convergent and divergent behavior? So I'd like us to think about an example to get started, and then we'll go through the answers to this example in the remainder of the slides. The first question is, what value could I plug in for x that's going to make this whole series, and therefore this whole function, be equal to 0? For the second question, I want you to think about other values that we could plug in for x and think about what happens to the series in those two different cases. For example, what's going to happen when I plug 4 in for x? Will this series be convergent or divergent? How about a different value of x? How about 3/2? If I plug in 3/2, what's going to happen to this series? Those are two examples of things we could do. And then last but not least, the real big question that we'll ask ourselves when we're working with power series is, can we find an interval of x values for which when we plug in those x values, we get a convergent series here? And it would make sense to talk about the value of this sum. So pause, take a moment, think about those things, at least answer the first two questions. And if you're stumped on the third, totally okay. But think about those questions, and then when you're ready, unpause, and we'll talk through the answers. Let's answer the easier questions first, and then in our next video, we'll handle that difficult last question. First, what value of x is going to make this whole function 0? Well, we want to plug in a value for x that's going to produce a 0 inside the sum so that the 0 will just multiply by all of those coefficients and make them 0, and we'll just be adding up nothing. And the value of x that's going to do that for us is a value of 2. So this is a way to make the series convergent in a very stupid way. If I just make it so that there isn't any sum at all, and I'm just adding 0 a whole bunch of times, then quite obviously the series is going to converge. But that's not really what we meant. So the first part of the second question was, well, I don't know, let's try a different value of x then, where it's not going to make that whole x minus 2 value disappear. Let's try an x value of 4. When I plug in a value of 4 for x, that x minus 2 term just becomes a 2, and it's raised to the nth power. So my whole series turns into the sum, as n goes from 1 to infinity, of n2 to the n. Now as I plug in different values for n here that get larger and larger, it's very clear that my addends are becoming larger and larger, and so I'm adding up infinitely many big things. This is obviously going to be a divergent series by our nth term test. Okay, so let's try something like 3/2. If I plug 3/2 in for x, you can see what the series becomes right here. 3/2 minus 4/2 turns into a negative 1/2 raised to the nth power. If I separate out the negative 1 raised to the nth power and the 2 to the nth power, putting that in a denominator, now we're really talking. This is a series that looks like it might possibly converge. Because this is an alternating series, you could use the alternating series test to show that this series does indeed converge. Or, even if you threw away the alternator, the thing that you're left with, n over 2 to the n, is a convergent series. So we're starting to get this picture that when I plug in one value, one specific value for x, which is called the center of the series, I'm going to end up getting a convergent series. Then there are other values that I could plug in to get a divergent series, and yet other values I could plug in that will give me a convergent series. And so what I would like is a method of approaching this problem that's going to tell me all the different x's for which this series converges, so that I can focus my attention on those particular x values, and our method of approach for doing that will be discussed in the next video.